Hello. Today we're going to go through IXL assignment SGL, interpreting circle graphs. So first, let's just freshen up our memory on exactly what a circle graph is. So a circle graph is sometimes referred to as a pie chart, and it is a way to just organize your data using sectors. So the sectors are the different sections here, and it always uses a circle. And as we can see, a couple things that stand out is we use different color codings with a key over here to the right, and we have percentages listed. So along those same lines, what are we looking for to make a good circle graph or to make a good pie chart, whatever you want to call it? We always need to have a title, which this does here, favorite pizza toppings. We need to have our labels, which we have on the right, the pepperoni, cheese, sausage, and supreme. It needs to be color coded, which we do have. Green is for pepperoni, purple is for cheese, etc. And then your data is represented either in a numerical form, so that could be by a number, a decimal, a fraction, or in this case as a percentage. But no matter how the data is represented, they always need to add up to 100%, because that would give us our total, because that 100% would be our total. So those are just some things to look for to know that you are interpreting and you are reading an appropriate and a good circle graph. All right, let's head on over to IXL to do the interpreting. So interpreting just means we are going to be given a circle graph and we need to read the data and answer questions based on what we're given. All right, we're on IXL, code SGL, interpreting circle graphs. And then quick little reminder, remember that IXL has some great helpful supports in here as well. So after you watch this video, if you want to see some more examples, you can either click this down arrow right here to see like what you would see kind of in a textbook where it goes through step by step how you would solve a problem. Or you can even watch a nice little video that IXL has made for you to see some other examples in that regard. All right, let's get to our first question here. A lumber yard in Columbia County keeps records of how much lumber it sells each year. And we have our different sections, they're color coded, they're labeled, and we have numerical data. And in this case, our numerical data is represented as fractions. Which list is arranged from the worst selling wood to the best selling? So we want the worst to the best. One nice thing about a circle graph is a lot of times you can kind of see based on the size of the sectors how many are in there and how big of a percentage it takes up. So we can use that to kind of give us a good idea of, the order from worst to best. And then we can, compare our fractions to make sure we didn't make a mistake, because sometimes there could be two sections that look pretty close together. So when I look at this, if it's the worst selling, that means they didn't sell very much. It's going to be the smallest section. And that looks to be this pinkish one, the fur. I'll just label it with F for fur. And then I'll put my fraction underneath so we can compare those in a minute to make sure they really do go in order from least to greatest or worst to best. So that one's done. And then, I got to decide between the purple and the orange, because those are relatively close in size. I'm thinking the orange is a little bit smaller, so I think oak would come next at 1/5. And then let's do purple, which is the spruce, at 3/10. That's a little bit bigger, I think. And then definitely the largest one would be the green one, which is the redwood at 2/5. All right, even though I feel pretty good that this is in order from the worst selling, so the least amount, to the best selling, the most amount, I want to compare my fractions to make sure a mistake has not been made. When we're comparing fractions, we need to make sure that our denominators are all the same. And we have two fractions with a denominator of 10 and two fractions with a denominator of 5. So I want to take the two fractions with a denominator of 5, and I basically want to unsimplify them. I want to multiply them by some number so they can have the same denominator of 10, and I can easily compare my fractions because they'll all be out of a base of 10. They'll all be out of the same number of pieces. Well, I know that I can take 5 times 2 and make that 10. So we'll multiply this entire fraction by 2, making it 2 tenths. And I can do the same over here. If I want to make this denominator of 5 10, 5 times 2 is also 10. So make sure you multiply the whole fraction, making it 4/5. And when I do that, I'm going to write the other ones just down again so I can compare. We can see that this does match up with what my eyes saw in regards to the sizing of our sectors, and it does go in order from least to greatest, so worst to best. 1, 2, 3, 4 happens to be numerical. So our answer choice is going to be the one that says fig, oak, spruce, and redwood. Or fir, sorry, it's fir. So here we go, fir, oak, spruce, and redwood. Be careful to read it because I was even getting, tripped up over my words. When it's very similar like that, it can be easy to pick the wrong one. So make sure you just double check things and don't rush yourself on this assignment. Next question. Kendrick, who just won the election for the student body president at Kingwood Middle School, tallied how many votes he received from each grade. And we can see our circle graph here. It looks good. We have all of our labels. This time our data is represented in percentages. And then our question is, from which grade did Kendrick receive the most votes? Well, in this case, since they're all percentages, I don't need to do anything with, changing those fractions. It makes it a little bit quicker to read and interpret our data. And we can see that 40% is the largest because we want to know the most votes. 40% is larger than 30, which the other two had. And when I look at my graph to kind of support that, the purple section does look larger than the orange or the green, meaning 8th grade is the grade where he received the most votes. All right, a supermarket in Newton keeps track of which kinds of bags customers use for their groceries. And this time we're back to our data being represented as a fraction. Which type of bag was used the most? So always look at your question carefully to make sure you're finding the right thing. We want to know which one was used the most. So that's going to be our largest portion. And if I just initially look at the sectors and their sizes, to me, it looks like this pinkish one right here, which is representing paper, that looks to be the largest. But again, I don't want to get it wrong and drop in SMART score, so I'm going to compare my fractions and double check my work, but I have a pretty good feeling it's going to be paper. So we have paper here with 1/2. And then we have plastic, so I guess I'll make that PL for plastic at 1/6. And then we have the green one, which is customer provided at 1/3. And if I want to compare my fractions, again, I need to make the denominators all the same. I'm going to look here. Well, there's nothing. When we make denominators the same, we're typically taking a smaller denominator, so a smaller number, and multiplying it by something to make it larger. And my largest denominator is a 6. So I'm going to see if I can make the other two have a denominator of a 6. For my paper bag here, I know that I can multiply 2 times 3 to be 6. So you'll multiply that whole fraction by 3, giving us 3/6. If I come over to that green section, the customer provided, that's 1/3. Well, 3 times 2 is 6. So I can multiply that whole fraction by 2, giving us 2/6. And then I'll just bring down the plastic one. And I can see my eyes did not deceive me. I was correct. 3/6. That's the largest out of our 3 different fractions here, meaning that the paper bag is our answer. That is the one that was used most. All right, let's do a slightly different type of question. I like this one here. Edmund owns 4 dogs and monitors how much food they eat in a month. And we're back to showing our data by percentages. If a total of 20 kilograms of food were eaten, how much more was eaten by Ginger than by Rocky? So that means the 2 pieces that we're concerned about is Ginger and Rocky. If I go back and reread the question again, because reading that question multiple times is key to make sure we understand what we're trying to interpret, what we're trying to compare here. And we want to know how much more was eaten. Well, that makes sense because Ginger has 30%, Rocky has 15. So if we want to know how much more was eaten, but it's not asking how much percent more. It's wanting to know the exact kilograms, and it's telling us that for this entire pie chart here, or this entire circle graph here, 20 kilograms of food was eaten. So that means 20 kilograms of food equals 100%. That's all that was eaten. So we need to find how much Ginger ate and how much Rocky ate. Well, this kind of brings us back to when we've worked with percentages in the past, and we need to find for Ginger, since she ate 30%, what 30% of 20 kilograms is. So remember, the first step is when you're trying to find percent of a number, is we need to change that percentage into a decimal. So we change our 30% into a decimal by moving your decimal point 2 places to the left, which gives us 0.30, otherwise just known as 0.3. And then we multiply that by whatever we're dealing with. So in this case, the 20 kilograms. So we're going to take our 20 kilograms and multiply that by 3/10. In case you need a quick reminder, I'll go through this on the board here. So 3 times 0 is 0, 3 times 2 is 6. And then if I were to multiply stuff by 0, I would just continue to get zeros. The thing to remember is where to put that decimal point. So if we look at our first number here, I don't have any numbers to the right of the decimal point because it would technically be here. But in this number, I have 1 digit following our decimal point, meaning in our answer, we need to have 1 digit that follows it as well, giving us an answer of 6. So Ginger had 6 kilograms of food. But we want to know for our final answer here, not how much did Ginger eat, but we want to know how much more Ginger ate than Rocky. So we also need to figure out how much Rocky ate. So we have Rocky over here eating 15% of the food. So once again, we're going to do the same thing. Whenever we take percent of a number, we move that decimal point 2 places to the left, giving us 0.15. and then we multiply that by whatever we're dealing with. So 20 kilograms times 0. Oops. Let's line that up better. Times 0.15. 5 times 0 is 0. 5 times 2 is 10. Now this is a good one because we have 2 digits here. Remember, whenever you move over to the second place value in multiplication, whether you're dealing with decimals or not, you put that 0 as a placeholder and then move forward with your multiplication. So 1 times 0 is 0. 1 times 2 is 2. When we add those up, it initially looks like a 300, but that's not our final answer. We need to deal with our decimal point. In our first number here, we don't have any digits to the right of the decimal point, but in our second number, we have 2 digits to the right of the decimal point, meaning we're going to need 2 digits to the right of the decimal point here, making this a 3. So Rocky had 3 kilograms of food. Well, how much more did Ginger have than Rocky? Ginger had 6, Rocky had 3. We can subtract to find out how much more Ginger had, and 6 minus 3 is 3, giving us a final answer of 3 kilograms. All right, it is now your turn to hop on IXL and work on this assignment. So go to SGL and work on the skill of interpreting circle graphs. And just remember those few little hints to read your question very carefully to make sure that you are actually interpreting the right thing. And then whenever you have questions like this that's seen, where it's going from most to least or anything like that, just double check that you have the correct order because, all of these choices look pretty similar. So take your time, you can get them right, and I know that you will rock this out. If you have any questions, make sure to reach out. Bye.